Here's a video demonstration of the Microsoft Sentinel log poisoning, log spoofing thing that I've been working on. This video is aimed to be short, hopefully, and just support the absolute monster of a blog post that I wrote recently exploring this topic. Um, so yeah, let's get started. This is the starting point here. So I've got two virtual machines here, one Linux, one Windows. You can see that that's all I've got on my in my subscription here. Both these virtual machines have system manager identities assigned to them to enable access to the metadata service. I'm not using user assigned managed identities, and there are absolutely no permissions assigned to these identities. So just by enabling them gives you access to the metadata service, which the Azure Monitor agent needs in order to send logs to Microsoft Sentinel. So both of these VMs are sending logs to Sentinel. I've got Linux sending syslog messages and Windows sending Windows events to Sentinel. So if we take a little look here, if I run syslog distinct computer here, I can see I've got just my Linux VM integrated. And then if I do event for Windows, I can see that I've just got, well, I have absolutely no idea what that bottom one is because this is a completely fresh deployment and I don't. Right, well, we'll gloss over that. And then I've got the heartbeat table. So the Azure Monitor agent sends periodic heartbeats to say I'm alive or whatever. Um, and you can see here I've got the Linux and Windows computers uh, logged for the heartbeat table. Cool. So let's get started. Now, the starting point for this is you need an access token for one of the managed identities. Now, I know that in a lot of cloud security stuff, initial access is always sort of glossed over, um, and this, to be honest with you, is no exception. Like, get onto a VM somehow. I mean, you don't need to get onto it, right? It could be an RCE. You could use Azure VM run command. You, it's not an outrageous requirement to get a metadata to steal a metadata token. Here I'm just using the serial console, which I'm probably going to pay for because it can be a bit temperamental. Um, so you don't actually necessarily need physical access to the machine, right? I haven't had to open an RDP client and get into it or whatever. But here you can see all I'm going to do is kill the metadata service, metadata slash identity, and I've got Azure Monitor as the scope. So if I paste this in, here we go, and I get an access token. Oh, this is so okay. Living in regret, I think it's about that. And once you've got this access token, that's it. You're done with the VM. You don't actually need access to it anymore. The way it works is we get the access token for the managed identity. We use that to go and create an ingestion token, and essentially that ingestion token is what's needed to actually upload the spoofed logs to Microsoft Sentinel. So I've written some Python code here that's not fit for human consumption yet. So please don't actually read it as I'm doing this. But I've just got the access token for a Windows machine. I'm just going to do the same for Linux. So here's that Linux machine I've just SSH'd in. Oops, didn't mean to do that. I just want to run the same metadata curl command on this VM. Here we go. And I've got an access token, which is much easier to grab for this machine. So how do you get a ingestion token? It's covered in detail in the blog. I'm not going to go into it too much, but you need to know the ingestion URL. Now you can infer it because it's your data collection endpoint ID. It's your subscription and the virtual machine name that you're on. So my Windows VM or my Linux VM. Then it's the DCR for that VM here, DCR immutable ID, and then the channel ID. Now the channel ID is just ODS. I'm not sure what that stands for. And then this GUID here, which is actually just it's the workspace ID, the Log Analytics workspace ID. Here we go. Sorry, that jumped around. That's what that refers to. And then it's just slash ingestion token or whatever. So what you do is you just set the access token as the authorization bearer, and that will give you an ingestion token. He says, so let me just rerun this, Python. Okay, and I think I've probably got something wrong here. sets groups. X. I expect my DCR is incorrect for that Linux VM. Bear with me. Uh, yeah, let's be something. Yeah, that's outdated. There we go. Right, let's rerun that. Cool. Right. Apologies. So I've got a Windows ingestion token and a Linux ingestion token. Now, the thing is, the ingestion these VMs they're tied to the DCR, which defines which data you can which you can send. So the Windows machine can only really spoof other Windows machines and heartbeat information, and it's the same for the Linux. The Linux machine can only really spoof Linux syslog messages and heartbeat data, but that's still not insignificant. So right, we have ingestion tokens for each of these. Let's start off that copy with heartbeat. So I'm just going to paste in that ingestion token here. I've got some more horrible Python that I don't want anyone to ever see, but essentially what we do is we set the header, but this time we set it to the ingestion token. Now, what's really, really significant here, what I think at least, is this. This is your resource ID. And what I'm going to do here is basically there are two endpoints for heartbeat, two URLs. You can send it in an XML payload, or you can send it in a JSON payload. The JSON is typically used for Linux, and yeah, the XML is used for Windows, but they all end up in the same table with the same schema, so you can spoof whatever you want, right, with these. Um, so yeah, I'm going to go for let's go for what's already uncommitted here, the XML version. And what I'm going to do is in my log, which I've just got as part of this, I'm just going to call my spoof machine I don't exist heartbeat XML. That's what it's going to be called. And I'm going to use the um, ingestion token from the Windows VM. Cool. Right. Sorry, that's a mouthful. Let's just run it and you'll see. So if I run Python heartbeat, I've got a HTTP 200 response here. Now the question is how quickly, the bane of my life, Microsoft Sentinel is. So now let's look at distinct computers on the heartbeat table, which previously just had two. If I run this now, I've got I don't exist HBXML. And if we take a little look at this, computer equals I don't exist heartbeat XML, you can see that it's got that full set of data in there. Now, what I really wanted to point out is the significant piece is this underscore resource ID. Now, the underscore data fields are meant to signify metadata that you can't change. But if you look here, that is spoofed. And the way that that's done is by this header here, Azure Resource ID. And I talk about in the blog that I think that Microsoft really should fix that. I think that essentially the ingestion token itself has a resource ID as a claim if you decode it. And I don't know why Microsoft don't just use that value in the authentication token as opposed to just some header string that anyone can just send, because it really undermines the integrity of that underscore resource ID, in my opinion. And that's a nice, easy fix that will really reduce what virtual machines can be spoofed, or at least provide the ability for analysts to write their own KQL query to cross-reference any submitted data against the underscore resource ID field, which I'll maybe show you at the end. So yeah, what could you do with a heartbeat? I mean, a lot of some KQL queries look at the heartbeat information. You could, fake machines. You could rack up some costly bills or something like that. I suppose there's lots of different things you could do with it. But let's move on. So the next one we'll do is Windows. So let me just grab my ingestion token for the Windows machine here. Where was it? Was it that one? I can't remember. Oh, I'll tell you what, I'm just going to run it again because I'm just going to get another one. There we go. Right. So I'm just going to grab that Windows ingestion token and update this. Again, horrible Python that nobody should ever see called windows.py, which I will update. Now, what this does is I've just got some XML data here from an old event, and it's got a computer in here called Windows-server. I've just recaptured that. I actually had to strip out some of the attributes in the XML to get this to work, which is interesting. Now, what it will do is, what will it do? It will set the ingestion headers, and it's going to spoof a machine called I don't exist Windows. So it's going to replace that, what was it, Windows dash server it was called, with I don't exist Windows. Now you've got to set, some headers to application XML, and this is a significant thing. All the data has got to be zipped up. So they use the zlib compression library in the Azure Monitor agent and upload all the data. So this is effective. Oh, and there's also some stuff here to like normalize timestamps. Actually, I don't think that method's nice. It is. I just rewrite the timestamps to a more recent time for this one. Cool. Anyway, so let me run Python 3 windows.py, and this is going to create a Windows event log, or a handful of Windows event logs with the spoof name I don't exist Windows. Cool. So that's sent, and that's given me a 200. Now, I think this one is going to be a little bit slower, but let's have a look. So previously I had, well, I actually had two machines on here, strangely, which I don't know why, PP something or other. Oh, there you go. It's come through straight away. I don't exist Windows. And let's just do the exact same thing again, where computer equals I don't exist Windows. Is that right? There you go. And it's actually, yeah, it's not just one log that's spoofed this time. It's a bunch of logs, and you can see the timestamps because that's that timestamp normalization thing I was doing. I was making up different timestamps every whatever that is, a couple of milliseconds. And when you've got more than one log, I think it really makes it look a lot more realistic here. And you can just sort of see that this is just completely fake, doesn't exist. So if we expand the, if we look at like the resource ID again, here, it's not just like the soft, I don't really call it, it's not just the computer attribute here that's been spoofed, although that's very significant because that's what all the KQL queries will pull apart. But it's actually that resource ID as well by setting that header, which has been spoofed. Okay, and then finally, let's have a quick look at the Linux one. Let me grab my Linux ingestion token here, and it's the exact same thing. Here I've actually got the logs just in the Python because it's just like a JSON dictionary. Just do JSON dump s or whatever. Same thing, going to replace the PC name with I don't exist Linux, and a bit of timestamp normalization, compress the logs before you upload them, blah, blah, blah. Python 3 linux.py. Cool, we've got another 200 response here. Happy days. Let's just see if that's actually in here. Syslog distinct computer. No, it's not. So this one might take a little while longer to come through. So whilst that's happening, because I think you still hopefully get the idea. What's interesting about this and the impact is like these look like real logs in terms of for Microsoft Sentinel. There's no way from the front end and from their analytics to determine that this is fake. So you could have a let me actually just update this to Windows event quickly. You can have an analytics rule that looks, that does legitimate defensive queries such as this. So, well, this isn't legit, but the point being is this should pick up a rule, pick up a create an incident based off the data that it's searching for. In fact, there's actually a little trick you can sometimes do here. I'll show you it. If you disable and re-enable a rule, I think it runs the analytics rule straight away, assuming if I've set this up right. There we go. And look, I mean, it's still called syslogs, but I've got loads of instance now, right? Based off of fake data, essentially. If I click events under this, can I get to it from here? It's not happy. There we go. Right, I don't know what's you've seen. I just clicked it from Sentinel, classic Sentinel. But yeah, you get the idea. I've got loads of fake alerts based on fake data now. So yeah, that's kind of the demo wrapped up, and there's a lot more information in the blog post. Brilliant, thank you. I realized it was just a minute later. I realized I never showed the I don't exist Linux logs coming through, but yeah, it's the same thing again. Where computer I don't exist Linux. just in case you didn't believe me. Here we go. And then again, these look really legit, these logs, but they're entirely spoofed.